I wish you all a very happy New Year today. As the winter is advancing, we are finding difficulties to operate, that is to take off or to land due to reduced visibility. The instrument which helps us during landing is what we call it as an instrument landing system, or in short ILS. So today I thought it would be very apt for me to cover this topic as the visibility are dropping day by day. The instrument landing system, or the ILS system, comprises of the following components. The ground equipments are the localizer, the glide path, the markers, and the approach lighting systems. The localizer is that signal which guides the pilot to be on the center line or extended center line of the runway by telling the pilot to either turn left or turn right. So the localizer antenna is located from the end of the runway by 300 meters or 1,000 feet. The localizer uses a frequency in a VHF band from 108 to 111.975 megahertz with odd first decimal. The first number after the decimal is an odd number, which is 5. Similarly, in this particular frequency 110.3, the first number after the decimal is 3, which is an odd number. If you recollect, this frequency band is shared with a VOR. It would have been a VOR frequency, it would have been 108.6. That means to say that the first number after the decimal is an even number for a VOR. But for an ILS, the first number after the decimal will be always an odd number. The localizer antenna transmits two overlapping lobes onto the left and the right side of the center line. The lobe which is onto the right side of the center line, it is modulated with 150 Hz of modulation, whereas the lobe onto the of the center line, which is also known as the yellow sector, is modulated with 90 Hz. So whenever the aircraft is onto the right side of the center line, it will receive more of a 150 Hz modulated signal. This time, the indicator which is inside in the aircraft will deflect onto the left, thereby telling the pilot to turn left so that the aircraft comes onto the extended center line of the runway. If the aircraft is onto the left side, which is also the yellow sector, he will receive more of 90 Hz modulated signal. At this time, the indicator inside the aircraft will deflect onto the right side, telling the pilot to turn right so that he comes onto the center line. Whenever the aircraft is onto the extended center line of the runway, he will receive equal amount of 90 Hz modulated signal and the 150 Hz modulated signal, and the needle here will indicate it exactly at the center of the indication, thereby telling the pilot that you are onto the right flight path. The coverage of the localizer antenna, that is in the horizontal plane, is that within plus minus 10 degrees of the center line, the signal can go, or signal range of the signal is 25 nautical miles. Within plus minus 35 degrees from the center line, the range is 17 nautical miles. In any of the sector, the range of the signal is 10 nautical miles. However, most of the localizer signals are calibrated up to a distance of 10 nautical miles. As far as the coverage in the vertical plane is concerned, the localizer signal coverage is 7 degrees. So now let us talk about the glide path signal. The glide path signal is that signal which tells the pilot how high or how low with respect to the designated flight path, that is a vertical flight path, which we call it as a glide angle. The glide path antenna are located up the beginning of the runway by 300 meters or 1,000 feet, and the antenna will look somewhat like this. As we mentioned, the glide path angle or the desired flight path, vertical flight path, is generally represented by theta. The glide path antenna transmits two overlapping lobes once again. The lobe, which is above the glide path, is modulated with 90 Hz, whereas the lobe which is below the glide path, it is modulated with 150 Hz. If an aircraft is above the desired flight path or the desired glide angle, the aircraft will receive more of a 90 Hz modulated signal, and the indication in the aircraft will be the vertical bar will be deflected downward, telling the pilot to go down so that he comes to the correct glide angle. Whenever the aircraft is below the desired glide path, he will receive more of 150 Hz modulated signal, and the indicator on the aircraft will indicate up like this, telling the pilot to go up so that he comes onto the correct glide path. So whenever the aircraft is onto the desired glide path, you will receive equal amount of 90 Hz modulated signal and the 150 Hz modulated signal. And at that particular time, this needle will be exactly at the center, telling the pilot that he is correctly on the desired flight path. As far as the standard glide angle is concerned, the standard glide path is generally 3 degrees. However, depending upon the terrain and the obstacle, this glide path angle may be adjusted from 2 degrees to 4 degrees. That means this theta can be adjusted between 2 degrees to 4 degrees. As far as the coverage of this lobe is concerned, this coverage depends upon the glide path angle theta. The minimum angle up to which one can receive the glide path signal is 0.45 of theta, and it can receive up to a maximum of 1.75 theta. That is the glide angle. So therefore, if we have to calculate for a 3 degrees glide path, the coverage will be from 3 multiplied by decimal 45, which is 1.35 degrees, and up to a maximum value of 3 multiplied 1.75, which is equal to 5.25. As far as the horizontal coverage is concerned, on the horizontal plane, the glide path signal coverage is 8 degrees. Marker beacons are the beacons which lets the pilot know the distance from the touchdown. These marker beacons are of 3 types. There is auto marker, middle marker, and the inner marker. All of them transmit at the frequency of 75 megahertz, which is a fan-safe marker beacon. Whenever the aircraft flies overhead, this marker up to a maximum height of 6,000 feet above the marker, you will receive the signal, and the indication inside the aircraft will be in the form of 3 different lights. Whenever the aircraft flies over the auto marker, the light inside the cockpit will be blue in color. Whenever the aircraft flies over the middle marker, the indication will be yellow in color. Whenever the aircraft flies above the inner marker, the indication will be in white color. The distance of the outer marker is generally located from 3 to 6 nautical miles, whereas the middle marker is 3,500 plus minus 500 feet, and the inner marker will be from 250 to 1,500 feet, which is published for that particular instrument approach chart. As I told you earlier, whenever you fly over the auto marker, you will have a series of blue light flashing inside the aircraft indication. Along with that, you'll be able to hear a low-pitch series of dashes, which is transmitted at 2 dashes per second at 400 Hz tone. Whenever you're flying over the middle marker, you'll be able to hear a series of dots and the dashes, which are transmitted at 3 dash and dots per second at the medium pitch of 1,300 Hz. And when you fly over the inner marker, you'll be able to hear a series of dashes at high pitch, which is transmitted at 6 dots per second with 3,000 Hz. With this, we will end the class for today. And in the next class, we will be talking about the indications of the ILS and the numericals, which generally comes on your examinations. Thank you, ladies and gentlemen.